Good morning, Anvi. I'm good, Anvi. Good morning, Sujata. Payaja, good morning. Suprabhat. बेटा what you call आज मैं today I'm starting with conic sections because syllabus we have to finish also other schools, but extra revision I have to give to all of you. School whatever questions they have given, one time we are going to check. Is conic section coming, Payaja? Is conic sections coming? Hmm. Ready? Now look here. We are starting conic sections. We need to understand that for conic sections, the most important part here is when a plane, three-dimensional sections, when it will be getting cut. So simple concept I am starting with so that you can understand. So conic section will be exactly one point, locus point will be there. That locus point will move in such a way that its distance from a fixed point, permutation, combination, binomial theorem, sequence and series. Straight line, first two exercises. Only this much is coming for test series. Okay. Hmm. Okay, so what I'm going to do is a special revision session I'm going to give for that. 2 3 days I'm going to give revision for that. But conic sections also I'm starting with that. So now look here. So for that we need to understand that one fixed point will be there. So whenever we talk about the line, we talk about the point. Directly I'm starting with the conic section content that is exactly considered as parabola, hyperbola, okay, ellipse. So parabola, what and all things are there, that first I am going to explain. For understanding that part, we need to understand what is latest rectum, what is other part. So one by one I am going to explain because syllabus I have to finish. So look here. So first for a parabola, we know that parabolic curves are what? This is exactly a parabolic curve. So parabolic curve, whenever we are writing y is equal to x square. So in junior classes, you have understood one thing, one simple concept you have understood. And that simple concept in junior classes, what you have understood that okay, this is exactly a curve. And whenever like this equation is there, this is quadratic. What it is? Quadratic. So for quadratic part, you used to write the equation ax square plus bx plus c. Y is equal to. Understood now? So in junior classes, when you were studying parabola. In that parabola sections, you were studying two, three important sections. The first important section is this is parabolic curve and this is ax square plus bx plus c. So whenever a quadratic equations you were always writing the quadratic equation in this format. Okay. So now we are specifically going to study parabola. Okay. So today right now we are going to study parabola. No here and there, just to the point parabolic content I am going to explain. See, usually what happens when a conic section you are drawing, you need to understand that what are exactly why the word conic sections have came. So here you need to understand that two inverted cones has been taken. Understand this concept. Two inverted cones has been taken, and in this inverted cones, you need to see that this is the axis point. Draw this one, you will be able to understand. So now what and all angle is exactly subtended here? This angle is subtended here is alpha beta. Understood? And this point is point of lines. So here you need to pair of lines. Here exactly you need to draw. So here pair of lines, so here one dotted lines we are going to draw. Got it? So now these are pair of lines. So whenever we are talking about, this part will become pair of lines. Understood? So these two pair of lines, one will be exactly passing. Divya, good morning, beta. So this part is exactly there and this angle is subtended here. So this is one part. So now if the plane, now we are going to cut this. These two cones are there now. We are going to cut these two cones. Got it? So this is exactly the axis point and this is the line. So this will become the pair of lines. Okay. Now next point is if you are going to passes the plane with the vertex. So now you are going to cut it. Now which shape you are going to cut this part, that will be exactly making a different type of figure. Are you understanding? So if I am going to cut like this, now check this one out, then it will make one circle. So whenever I am going to cut this with an axis like this, got it? So now this will become the center point, correct? So here theta will be exactly with, this is the plane. This is the plane with which we cut the cone. So when we cut the cone with this plane axis, so here what is theta? Theta is equal to pi by 2 90 degree. Because this part is exactly going straight now. So we have just cut. So how many cuts you will do, that many circles you will get. How many cuts, straight line cuts you will do here, that many circles you will get. Is it clear till here? So beta, this is exactly when the cones will be, two inverted cones will be getting cut with theta is equal to pi by 2, it will make circles. So it will make bigger circle. So definitely when the cones will get cut, it will become circle. This is the first part. Now second part. So when second part we are going to understand, here the cut will not be the circle. So that means theta is equal to pi by 2. Means the plane when cut these cones in that total 90-degree axis, it will be coming as circle. So whatever figures you are going to draw. Okay. Good morning, beta. So beta, whenever you will be exactly cutting this, it will always make circles. Okay. So now beta, next part. When you will be taking the plane and cut like this. So when you will be cutting like this, it will not be considered at that case circle. That time it will become ellipse. That time it will become what beta? Ellipse. I'll explain everything. The basic sections of conic section 1 which you will understand the entire part. So beta, this part whenever you will cut like this, what it is exactly going to make? Ellipse. So for ellipse you might have seen that the theta value is the angle with which you are cutting. For ellipse region, it will be exactly theta should be greater than alpha. Now, did you notice one thing, beta? What is exactly the alpha section? Alpha section is exactly this section where it is exactly cutting. Yes, so definitely theta should be greater than alpha, but theta should be less than pi by 2. Then angle should be less than pi by 2. This is the most important thing we must remember at the time we are discussing ellipse. Understood? So ellipse will be having how many directrix? So here we are going to talk about the ellipse directrix. Two directrix will be there. Understood? I will explain what is directrix, how it is drawn. Every part I am going to explain, but this part it is exactly two cones will be there and they will cut with some axis. This will be exactly considered as what beta? This will be considered as ellipse. For ellipse, the angle with which it is coming, the alpha will be exactly, it should be greater than alpha, this angle, and less than 90 degree. Okay, so this is coming as ellipse. The next part is if when you will be drawing parabola. Parabola cut will be what? How parabolas are exactly contained from the ellipse. So two conic sections, two cones we are going to take. Now how the cut will be? Already I told this part will be coming from the axis. Okay. So now next section beta. So when you will be cutting, how you are going to cut? You will cut like this. This is exactly considered as parabola. Understood? So like this cut whenever you will come, when you will get here theta will be definitely equal to alpha. Everything is having a specific angle, a specific detailing in conic sections. So definitely the moment theta will be equal to alpha beta, it will be making parabola. It will be making parabola. So whenever, because this angle is exactly subtended as alpha. So whenever theta will be equal to alpha, can you, whatever axis is exactly going to draw, so theta will be equal to alpha, definitely theta will be equal to alpha, it is called as parabola. This part will be considered as what? Parabola. So like this, many cuts we will do, it will be considered as what? It will be considered as parabolas. Got it? But only one thing, theta should be equal to alpha, then it will be considered as parabola. In the same reason, if we will be cutting it with the same axis like this, two cuts are generated. This time it will be called as hyperbola. Understood? This content will be exactly considered as hyperbola. This part will be coming as what, beta? Hyperbola. So this is exactly the difference between parabola will be single, hyperbola will be double cut like this. So here one directrix line, whenever you are going to draw, it will be cut from the 2 points. So that we are, once we are going to start that section, we are going to understand. So now there are certain points in conic sections which we are going to understand. First, we will start with parabola. But before starting with parabola, definition of conic sections, one locus point is the cones. Locus point will keep on moving in such a way so that a symmetrical figure you are going to get. That's the definition. But what is exactly the meaning of focus? What is eccentricity? What is directrix? What is axis? That you must know. Okay. So that once you are knowing means it will become very easy for you. So first, what is the meaning of focus, beta? Because focus is one of the major point for parabola, ellipse and hyperbola. Understood? Parabola, ellipse and hyperbola. So what is focus? Focus is a fixed point. That's it. What is focus, Nishika? Focus is a fixed point. So if somebody will be asking you what is a focus, so one single answer you are going to do, fixed point. Understood? So this is exactly a point which is fixed in the conic section. It is called as focus. So what is focus? So first we are going to understand focus, the fixed point or a fixed point, a fixed point or the fixed point. The fixed point is called focus. The fixed point is called as what, beta? Focus of the conic section. So focus is the fixed point of the conic section. This is one thing. So whenever we are drawing, the focus will be fixed in the axis. Understood? So if I am drawing a parabola, so in that parabola, focus will be fixed here. Got it? So if I am drawing ellipse, that time two focus will be there and it is the fixed point. Understood? So this is the fixed point. If I am drawing hyperbola, then too also focus will be fixed. So all the sections, whenever we are drawing, the focus will become the fixed point. Then where is the focus in case of circle? Correct now? So at the case, the focus will be exactly the center. Understood? So that case, the focus will become the center. So I hope because theta is equal to 90 degree, that time it is coming. So what we have learned, beta, the fixed point in the conic section is considered as focus. Understood? And I have drawn all the figures to explain you which place focus is lying. So this part focus is there. Here these are the two focus. Center of the circle will become the focus and here these 2 points will become the focus. So focus is considered as the fixed point in the parabola. Understood? So now directrix. So because when we were drawing direct two cones now, you might have seen that I was drawing one dotted lines. Correct now? So I was drawing one dotted lines. So let's talk about that part. Okay. So now next part is considered as directrix. So once you will understand the directrix content, you will understand many parts. So now look here. What is directrix? Remember this part. This is very, very important for class 12. So directrix. Directrix. So the next part is considered as what? Directrix, beta. So the second section is considered as directrix. So what is directrix? The fixed straight line. So here focus is a fixed point, directrix is a fixed straight line. Okay. So write the fixed straight line. Nishika, note down the fixed straight line. The fixed straight line. The fixed straight line is called directrix of the conic section. Is called I hope you might have understood better. So first point what we have learned, focus. Understood. So focus is a fixed point in the conic section. In the same way, directrix is a fixed line. So for parabola where we are drawing the directrix, see look here, for parabola we are drawing the directrix opposite of it. So this is the fixed line and this fixed line is considered as what beta? Directrix. For ellipse, where is the directrix? So this is the ellipse. So directrix will be here and here. Understood? So these are the directrix. I am just denoting it with blue color. So this is the directrix line. The fixed line is exactly considered as directrix. So here this is the fixed line. So this is considered as directrix. Now next one. When you are drawing a hyperbola, where is the directrix? So this is exactly the hyperbola. So for hyperbola, the directrix will be these two lines inside. So please draw this and note down where and all directrix are there beta. So this is exactly directrix. This is directrix. So for ellipse and hyperbola, for parabola, one directrix line will be there. For ellipse and hyperbola, how many directrix line will be there? Two directrix line. Here is it clear? Focus is the fixed point. Directrix is the fixed line. And the third important point is eccentricity. So three major sections in. Is my voice audible? I'm so sorry. I did not put. Is my voice audible, Vita? Everyone, my voice is audible. So, because this is the fixed straight line. This is exactly a fixed straight line, fixed straight line, fixed straight line. So, this is the definition of, thank you, Vita. This is the definition of what? This is the definition of directrix. So, where fixed point and fixed line. And the third and the most important thing, the entire game is for focus, directrix only beta. When we are studying conic section now, we need one fixed line and fixed point. And with that only we play the entire game. Okay. So now next comes the eccentricity. Note down eccentricity. Next comes the eccentricity. Okay. So when somebody will be asking you about eccentricity, what answer you are going to say? The answer is the constant ratio. The constant ratio is called eccentricity of conic section. The constant ratio. I'll explain what is the meaning of constant ratio. The constant ratio. The constant ratio, understood, is called eccentricity. Is called eccentricity in conic section. The constant ratio is considered as what beta? The constant ratio is considered as eccentricity in conic section. But what is the meaning of this constant ratio? I am going to explain you. But eccentricity is denoted by E, put E. Understood? The small e is considered as eccentricity. Now only the three major sections were there. First is focus, directrix, eccentricity. Conic section is all about this. Next part is axis. We already know that x-axis and y-axis plays the crucial role, and whatever figure you are going to draw, the figure will be symmetrical either along x-axis or it will be along y-axis. Like here, if you are drawing a parabola, definitely if you will fold it, it will be symmetrical. Understood? So when you are going to draw an ellipse, So that means you check this one out. When you are going to draw an ellipse, what you are going to see, the axis is exactly. So when ellipse you are going to draw, you will fold it. So four folds will come. That is what? It will be symmetrical along x-axis and y-axis both. Like this figure will be there. So axis plays a crucial role at the time when we are learning conic section. The next important point beta. So axis, I hope you have understood. Axis means x-axis and y-axis, and whatever the figure will be, it will be either symmetrical to x-axis or it will be symmetrical to y-axis beta. After that, center. We know center is most important. For every parabola, hyperbola, ellipse, circle, we will always be generating a center, and from that only the fixed point will keep on rotating. Understood? Now comes latus rectum. Latus rectum. This part you understand. Vertex point to already you know. कि whenever you are exactly drawing any figure, the turning point will considered as the vertex point. So for parabola, for hyperbola, for ellipse, where and all are the vertex point beta? First we need to check this one out. So when you will be drawing like this, so this one will become the vertex point. Let's find the vertex point. This will become the vertex point. So this is the vertex point. Okay. Now when you will be drawing ellipse, where and all is the vertex point? So definitely it will have vertex point here. So these are the vertex point. Got it? So this will be the vertex point. This A dash and A are considered as the vertex point. When we will be drawing hyperbola, at that particular case beta, where is the vertex point? This is considered as the vertex point. So definitely we have come across most important points. Now beta, next part, latus rectum. So you need to understand that one line will be drawn. In circle when you were studying, that time you have learned about chords. Correct, Navita? So when you were studying circle, that time you were discussing that this is the chord. You used to say that, auntie, this is the chord. The longest chord is the diameter of the circle. The longest chord is what? Diameter of the circle is considered as the longest chord. So beta, like this only, when you are going to draw, ordinate, double ordinate, that particular sections, that will become latus rectum. So the latus rectum will be what? Which will be passing through the focus. Always ordinate. So now look here. I'm just going to draw it and I'll tell you what is the latus rectum. So if this is the parabolic figure, in this parabolic figure, if any lines you will draw, this is called as double ordinate because it is coming straight. So this is like not called as chord, it is called as double ordinate, or it is called as double ordinate or ordinate. Because when this ordinate will pass through the focus. So when a line is drawn perpendicular to the curve and passes through the focus is considered as latus rectum, LR. It is considered as what beta? Latus rectum. So many lines we can draw. Understood? You know na कि diameter, what the longest chord of the circle is considered as diameter. The longest chord of the circle is considered as diameter beta. In the same particular way, the line which touches, which will be perpendicular to the axis touching the curve, passes through the focus is considered as what beta? It is considered as latus rectum. The entire story finishes here. Conic section over. Understood? The concepts of conic section depends upon three major things. Remember nicely. First is, which is very important, focus, directrix, eccentricity. But between eccentricity I did not explain to you. Still now only I told that the ratio is called as eccentricity. But what ratio is called as eccentricity? That also we must know now. What ratio is considered as eccentricity? So now I am going to explain you what is the ratio which is coming as eccentricity. And beta, I told you, entire conic section is dependent on three factors. What are the three factors? First is focus. Focus is a fixed point. Next one is beta directrix. Directrix is a fixed line. Eccentricity is ratio. But what is fixed point, fixed line, and ratio? Now we are going to talk about this. Now look at it. Whenever you are going to draw this one and try and understand this one. I told you now the three main heroes of this movie is directrix, focus, and eccentricity. But from where it is coming? Now, better listen nicely. So maybe this is the origin. Okay. Now this is directrix. This fixed line is considered as directrix. In conic section, beta, last part when I was drawing a cone, I draw one line now, and I told that it is exactly the angle with which the line is making. That line was called as two lines. One straight line I draw, one slant line I draw. Correct now? So one line, the slant line what I was drawing, I told now this is a fixed line. This was what? Fixed line. So now better this fixed line we are going to generate, we are going to call it as a special name Z dash, and this line is called as directrix beta. What this line is called as directrix. Now better this become the fixed line. Okay. Now this directrix is touching the axis at M. So now this part we got. So this is what directrix. Okay. Whatever point is there, I am going to explain. So here what we are going to do is we are going to write. So this one will become X. This is exactly X dash. Now this one is Y, and this one is Y dash. What did I say, beta? A fixed line is considered as what? The fixed line is considered as directrix. Done till here, beta? Now next point. Now I told you one fixed point will be there, and that point will be considered as focus. So now beta, we are going to draw focus here. So this will become your focus. The fixed point is considered as focus. Now till here it is very confusing. So this is the fixed point that is called as focus. This one is what beta? Focus. And the fixed line is called as directrix. I told you the entire story. Now beta, one arbitrary point will be there. That arbitrary point will be point on the curve. Okay. So we are going to take one arbitrary point P, and we are going to denote it with H and K. So this is considered as arbitrary point. And beta, what is the meaning of arbitrary point? The point which moves on the curve. It will not be out of curve. Understood? So if I am going to draw a parabola, in that parabola this point will be there. If I am going to draw an ellipse, in that ellipse this point will be there. If I am going to draw a hyperbola circle, every time this arbitrary point will be there. And this arbitrary point is that point on the circumference part of the curve. So this is the most important thing. But we have to find this arbitrary point will be present in the curve, and it will be moving on the curve. Beta. It will be present in the curve and it will be moving in the curve. But what we need to do? We need to find the ratio. That's what I told you now. So this is exactly done and done. Got it? So this will be M point I have taken. This is perpendicular. So PS by PM. This is the ratio. This is the ratio. This is our fixed point. This is our fixed line. Got it? And the ratio between them is eccentricity. Then that's the entire story, and nothing else is there in conic section. So what you are going to write? PS by PM. PS by PM is equal to E beta, and this is eccentricity. The ratio between the fixed point and fixed line is considered as eccentricity. I hope you might have understood. Come on children, can you tell me till here you have understood? This is one of the most important sections of conic section, and you should give a proper time to conic section to understand. Understood? Nothing big, I made only to the point content. Three important things are there: directrix, focus, eccentricity. So beta, the ratio between the arbitrary point, what they are making with a 90 degree, they are making with the line, the fixed line. And here it is making some angle with the focus. So PS by PM is equal to eccentricity. Come on children, PS by PM is equal to what beta? Eccentricity. That's it. Now, there are certain cases we are going to study about eccentricity. So now we can solve this one also, because here we have taken this point as h comma k. Then we have taken that point as h comma k, and we can, what is the equation of this directrix line? Because it is a line now, directrix is a line. So its equation can be ax plus by plus c equal to 0. This will become the equation of the line, and this is exactly the fixed point beta. So you need to solve it, means you can solve also. So now ps by pl. So we can say ps square is equal to e square pl square. Now beta, what is ps? ps is distance now. So here this part will be exactly equation part when you are writing. How you will write ps? So here this is equation circle. So we can write h minus k whole square h minus alpha. So we need to write some value. So let's take this one as alpha and beta. Don't say I'm just taking x axis. So here beta part will become 0. Okay. But what we are doing is if we can't write it on the axis, then alpha beta both will be there. Don't have this confusion beta. On the axis, if focus is coming, then alpha beta will not be there. Only alpha comma 0 will be there. But we, for understanding, I am writing above axis, means once upon a time when it is not on axis, it is above axis. Okay, the focus point. Then what will be the distance formula beta? We know our distance formula, we can write h minus alpha whole square plus k minus beta whole square. This will become an e square. And what is pm beta? Pm is the perpendicular distance. And you know what is the equation of perpendicular distance? The equation of perpendicular distance is this part, this point will be, and that is whole square. So this is exactly the ratio, and this is the part in eccentricity. Now you know, after solving this, we are getting a Cartesian equation, and that is the boss of every equation. Because from their circle equation is coming, from their parabola equation is coming, from their hyperbola equation is coming, from their ellipse equation is coming. That means we learned only one thing: do one small work, and that small work is take one cone and fix that cone on another cone, draw one line and draw this line with which you are exactly the this line, and then start cutting. So whenever you are cutting, you are getting different type of figures. Understood? Now net is okay, better. Is the video struck? Okay. Shall I continue, beta? Shall I continue? This is the most basic things, beta. Don't go here and there. Don't read unwanted, not needed. What is the most important thing is the basic ideas what you are reading. Okay. So here this equation is coming, beta, and after this you have to remove h and k, because beta that is the arbitrary point. H and k is the arbitrary point. So h can become x and k can become y. Understood? So now h and k will become